Coffee is second only to water in terms of worldwide beverage consumption. Although the most prominent ingredient in caffeine, I'm sorry, although the most prominent ingredient in coffee is caffeine, many of the health effects associated with coffee are not from its caffeine content, but rather from other substances contained in coffee, such as various polyphenol compounds that provide potent antioxidant activity. Indeed, for most people, coffee is the primary source of antioxidants. A lot of people don't take vitamins. They don't take vitamin C. They don't take vitamin mineral, vitamin E. Their main source of antioxidants is coffee. Drinking coffee, because of its antioxidant content and because of somewhat related to its caffeine content, drinking coffee is linked to lower rates of diabetes. It can lower the incidence of diabetes by as much as 42%. It lowers the rates of cardiovascular disease, although this is a U-shaped curve, meaning that if you drink too much coffee, especially in certain susceptible individuals, it can actually increase the incidence of heart rhythm disturbances. That's one of the signs of too much caffeine. You get disturbances in your normal heart rhythm. Many types of cancer are also prevented by drinking coffee. And again, it's not really the caffeine content that does this, it's the polyphenol, it's the other compounds in coffee. Some studies suggest that drinking 3 to 4 cups of coffee a day helps to lower the risk for both Parkinson's disease, which is a degenerative brain disease, and Alzheimer's disease. I think, uh, I think if I remember correctly, drinking something like 4 cups of coffee can lower the risk of Alzheimer's by as much as 50%. This is likely related to the antioxidant activity provided by coffee. More recent studies suggest that coffee may help to prevent a condition called non-alcoholic fatty liver. This is currently in epidemic proportions. In the United States alone, 51 million Americans are estimated to have non-alcoholic fatty liver disease. This is very serious because non-alcoholic fatty liver disease is a precursor for insulin resistance, diabetes, cardiovascular disease, and possibly even cancer. Coffee, again, drinking coffee helps to prevent this non-alcoholic fatty liver, which is, every other person you pass on the street. You don't have to be fat, by the way, even though it's called fatty liver. A lot of slim people have this too. I'll have an article in my Applied Metabolic newsletter about this non-alcoholic fatty liver disease, what it is, how to prevent it. But in essence, let me put it this way. A lot of it has to do with lack of physical activity and eating too many refined carbohydrates, especially fructose is related to that, but that's another story. Although caffeine is best known as a stimulant because it blocks these receptors in the brain for a chemical called adenosine, which is a very relaxing chemical. Little factoid here. You don't want to take in a lot of caffeine before you work out. I know some people like to really, drink a lot of coffee or possibly take caffeine tablets. I don't think it's that great an idea because adenosine in the brain, like I say, it's related to the onset of sleep. It's a relaxing chemical, and caffeine provides the stimulant effects by blocking adenosine receptors. There's two of them. I think that maybe at least two, maybe more adenosine receptors, but I know that caffeine blocks at least one of them. By doing so, it provides a stimulant effect because it basically wards off feelings of fatigue and tiredness. However, another lesser known effect of adenosine is it dilates coronary arteries. When you're working out, you want to have maximal coronary artery dilation to deliver oxygen to your heart. And adenosine is involved in that process. If you drink too much coffee or take excessive caffeine, by blocking the adenosine, you're making your heart work harder during exercise. Moderate amounts of caffeine is not bad. It's not going to hurt anybody. But if you already have heart disease, or if you already have heart problems, it's probably a good idea not to take in any caffeine before you work out. And my next video, I'm going to be discussing why some people respond differently to caffeine. And also, I'm going to explain why some studies involving weight training show that caffeine provides a tremendous ergogenic effect. Other studies show that it doesn't seem to do anything, and there's a reason for this that was recently discovered, and I'll be talking about that in my next video. You should also know that caffeine has been known for years, since the 70s. It's been known that caffeine found in coffee stimulates fat metabolism. In other words, what it does is it stimulates the release of chemicals called catecholamines, specifically epinephrine and norepinephrine. These catecholamines, in turn, stimulate an enzyme in the fat cell called hormone-sensitive lipase, which serves to help release fat from fat cells, where it get the the triglyceride molecule is broken down into glycerol and free fatty acids, and the free fatty acids then enter the blood, where they're subject to oxidation by exercise. If you don't exercise them, they just circulate for a while and go right back into the fat cells. They're a process called reesterification. I don't want to get into the biochemistry here. Now, the really interesting thing, here's the thing. The other day I was like perusing some new studies, and in my Applied Metabolics newsletter, I got to tell you right off the bat, I have a policy. I don't like to write about animal studies for a couple of reasons. The main reason being that humans are not mice. We're not rats. Some of us are rats in a certain sense, but there's a difference between humans and animals, and we don't have the exact same physiology. Animal studies, if anything, are just preliminary studies. They're not the end result. Like a lot of these blogs, these science blogs and these websites, they kind of write about mouse studies, and they act like it's if a mouse, for example, ingests a certain substance and gets cancer, these blogs will write so-and-so substance causes cancer. Now, what it did, the substance caused cancer in mice. It doesn't necessarily mean it's going to cause cancer in humans. For one thing, mice and rodents are far more prone to cancer than humans, so there's a big difference there. Another thing you have to understand is that when they're trying to produce a drug, when drug companies are trying to produce a drug for sale, it has to go through a certain process of testing. First, they have what they call in vitro or isolated cell testing. Then you have animal testing. If the drug passed the animal testing, then it goes into what you call human trials. And if the human trials show that the drug produces more benefits and side effects, the FDA will approve it, and it's put on the market for sale. Now, what you should know is that 92% of the drugs that pass the animal testing phase fail in human testing. In other words, 92% of drugs that worked for animals didn't work for humans. That's something to keep into account. Keeping this all in mind, I actually came across a mouse study. And again, I don't like to even talk about mouse studies for the reason I just said, but this mouse study was so interesting that I thought that I would do this little video about it, because the processes involved are also duplicated in the human body. So this may also apply to humans, but I quickly hasten to add that for this study to be relevant to humans, it has to be replicated for humans. You'll see the authors concluded their study of this mouse situation by saying that they basically acted like it's relevant for humans. Now, I don't agree with that. It may or may not be, but let's talk about what the study said. Well, first, let me tell you that getting back to the coffee thing, a study of 2,578 people found an inverse association between drinking coffee and the onset of sarcopenia, and it also prevented the progression of sarcopenia in old mice. What is sarcopenia? Sarcopenia literally means the loss of muscle mass with age. And this study of over 2,000 people, humans, found that drinking coffee seemed to prevent the loss of muscle with age, and it was originally shown in a mouse study to do that, and then they did a human study, and they did find it also blocked sarcopenia in humans. So in this case, the mouse study was transferable to human study. That's important to consider because of the following information I'm going to give you about this new mouse study. The new study involved mice who were fed diets that included either 0.3% coffee or 1% coffee. And a 132-pound man, are you wondering why I'm saying 132-pound man? Because this was a Japanese study, and I guess the average weight in Japan for men is about 132 pounds. So that's what they list in the study. But in a 132-pound human, this amount of coffee that was given to the mice corresponds to drinking 1 to 3 cups of coffee a day. Previous studies have shown that coffee accelerates the healing of injured muscle in aged mice and also boosts satellite cell proliferation. Satellite cells are muscle stem cells that are involved in the repair and growth of muscle. When you stimulate muscle satellite cells, you also are tending to increase muscle hypertrophy or growth. So they're very important. And the mouse study, the previous mouse study, show that providing coffee to the mice stimulates satellite cell proliferation. In a minute, I'll explain exactly how that happens. But in the new mouse study, providing coffee to the rodents increased the activation of a substance called P38MAPK. Again, I'm not going to go into detailed explanations of what that is, except I will tell you that it's involved in what they call muscle cell differentiation, which is basically what the satellite cells do. They basically provide, I don't want to get into the complexity, but it involves the growth of, let's say, the production of new muscle cells. You can say that, or the expansion of existing muscle cells. And this is a process involved in muscle hypertrophy. Coffee also increased the activity of another substance linked to muscle growth called myogenin. Myogenin is what they call a myogenic factor that's, again, involved in the muscle hypertrophy process. Now, what caused the increase of these substances? The effect was traced to a substance called caffeic acid. Caffeic acid is produced from one of the polyphenols in coffee called chlorogenic acid. Interestingly enough, chlorogenic acid itself has a couple of health effects. It basically helps to blunt the release of excess glucose from the liver, so it's good if you have glucose problems. But chlorogenic acid itself doesn't affect these myogenic factors. Only its kind of metabolite, caffeic acid, does. Activating P38MAPK also induces the expression of another substance called PGC1A. PGC1A is best known for promoting the development of new mitochondrial cells. The mitochondria are the portion of the cell where energy is produced as ATP and fat is oxidized in a process called beta oxidation. So the more mitochondria you have, usually the greater the rate of fat oxidation and the greater the muscle endurance because of the production of energy. One theory of aging holds that your cells age when mitochondria start to die off, because mitochondria are the powerhouses of the cell. They provide energy for the cell, and if the mitochondria disappear, the cell lacks energy and undergoes a process called apoptosis, or self-suicide, and dies. This happens on a gradual basis, but eventually it's recognized as aging. So the PGC1A is a very important chemical or substance for stimulating your mitochondria development. Now, besides stimulating mitochondria, PGC1A also provides anti-catabolic effects in muscle by suppressing a major catabolic pathway in muscle called the FOXP03 pathway. When this pathway is activated, your muscles break down. They're catabolic. And PGC1A blocks the effect of that catabolic pathway. And as I said, substances in coffee stimulate PGC1A. You could also stimulate PGC1A, by the way, by just doing aerobic exercise. That alone stimulates PGC1A. And when you stimulate PGC1A, you also decrease muscle fatigue. You'll also be able to train a lot harder with less rest between sets and so on and so forth, greater recovery. Now, caffeine boosts the activity of another substance. Caffeine itself boosts the activity of a substance called AMPK. Again, I'm not going to go into I'm going to have an article in Applied Metabolics about AMPK, very important substance, especially in the aging process. But, from a negative point of view, AMPK works the opposite. It tends to inhibit muscle protein synthesis. So AMPK does a couple of good things. It's involved in fat oxidation in muscle, promotes fat oxidation of muscle, does a couple other good things, but it also inhibits muscle protein synthesis. The polyphenols in coffee tend to blunt the phosphorylation of AMPK, which is a technical term for the activation of AMPK. So by blunting the effects of AMPK, coffee would also provide an indirect anabolic effect. While coffee blunts the activity of caffeine blunts the activity of an anabolic signaling factor called AKT, Coffee promotes the activity of this substance, which is again an anabolic effect. AKT is also involved in that process of satellite cell differentiation, muscle hypertrophy. Coffee also, and this is all from the mouse study, coffee blunted the effects of transforming growth factor B. I know there's a lot of technical terms, but there's no other way to express this. But I will tell you that TGFB causes muscle fatigue and weakness. It causes muscle loss and weakness. TGFB tends to rise with age and is considered one of the primary factors of muscle loss with age. And coffee blunts this particular substance, which probably explains why it also halted sarcopenia, the loss of muscle, in mice and older Korean people. As if this wasn't enough, coffee also blunted the release of myostatin. Myostatin is a protein that's produced in muscle that blunts muscle growth. And coffee actually blunts the release of myostatin. It's incredible. And coffee also boosted the intramuscular production of insulin-like growth factor 1, which is probably the most anabolic anabolic hormone produced in muscle. Coffee also increases the phosphorylation or the activation of both AKT and the mammalian target of rapamycin or mTOR. mTOR is the major effector of muscle protein synthesis. Now, even though, this is all amazing stuff. I mean, on the surface, if you look at all this, it almost seems like coffee is more anabolic than anabolic steroids. Of course, we know this isn't true, but the mere fact that coffee itself, not caffeine, but coffee in the mouse, stimulates all these anabolic pathways while blunting at the same time the breakdown of catabolic pathways, indicates that drinking coffee is really good for you if you want to build some muscle and you want to prevent muscle loss. That's the bottom line. I'm not saying that drinking coffee is going to produce the effects of steroids. What I'm saying, it's an additive effect. And, if you're worried about the health effects of coffee, don't. Unless, again, you have certain genetic problems, which I'll discuss in another video. But for most people, especially people involved in working out, coffee is one of the best beverages you can drink. Now, these authors concluded the study, even though it was a mouse study, the authors concluded by saying, here's their exact quote: "These results suggest that 1 to 3 cups of coffee per day in humans may promote skeletal muscle hypertrophy and myogenic differentiation and prevent muscle loss or weakness by disease or sarcopenia." Honestly, I think that's a little bit of a leap. In other words, these authors are doing the same thing those internet blog people do. They're kind of extrapolating an animal study to humans. They're already saying that drinking coffee is going to cause muscle hypertrophy and also prevent the loss of muscle, especially the loss of muscle with age, called sarcopenia. I honestly wouldn't go that far. What's needed now is some human studies to confirm this effect in humans. In other words, this was a mouse study. It may or may not be applicable to humans. However, it's important to note, all the pathways that I discussed in this article exist in humans, and they work the same way in humans as they do in mice. So there's probably a good indication that coffee has a slight anabolic effect. Therefore, it's good for you if you're working out. It's good for you if you're trying to build muscle. So that's it for the anabolic effects of coffee. If you want further information about nutrition, supplements, hormonal therapy, ergogenic aids, anti-aging research, fat loss techniques that really work, exercise science, subscribe today to my Applied Metabolics newsletter, www.appliedmetabolics.com. Again, I don't really talk about a lot of animal studies because, again, a lot of them aren't applicable to humans, but the stuff I talk about is all evidence-based, and I give you practical ways to use this information. I also impart my 56 years of constant study and an experience in the gym, empirical experience, so I could prevent you from making some of the common mistakes made by people that prevent them from either losing body fat or making muscular gains. So again, subscribe today. I call it a newsletter. It's more like a monthly ebook, 40 to 50 pages, solid information, written in plain English. I explain all technical terms. You don't need a science degree. www.appliedmetabolics.com. I promise you, you'll learn something. If you want to have the best friend you'll ever have, go to your local shelter, adopt a dog. Great animals. Terrific. Take care.